Here we go. We're going to review for this test. And let's just do the first one. There's actually, I'm not going to write all this down, but you might want to. The first two problems are to find the geometric mean. And it says find the geometric mean. I'll put GM for geometric mean. Between, I'll put BW for between, like two numbers. So let's say, I don't know, 2 and 5. Is that the one? Is that the numbers they had on the worksheet? Something like that. All right, so what if I asked you to find the geometric mean between these two numbers? How do you set that up? Yeah, you set up a ratio, right, or a proportion. You put x on the top and x on the bottom, different sides, right, diagonally to each other. So that's the geometric mean. That's what you're solving for. Everybody should be able to do this one, okay, because you're going to have to do this several times in another problem. At the very, very least, you should be able to find the geometric mean if I give you two numbers. So you put the geometric mean here and here, and then you put the two numbers here and here, okay? So they're diagonal to each other. And then you just cross multiply. That should be the easy part. So x times x is x squared, 2 times 5 is 10. Take the square root of both sides to get x by itself, so x is the square root of 10. There's two problems like that on the test, all right? So you may want to jot that down. There's two of them. All right, let's move on. We're going to use geometric mean to do this next thing. This is where you have that right triangle and an altitude. Remember that? Yes? No? Okay. Yep, that's the altitude when it goes not just straight down, but what? Perpendicular, right. This is 3, 4, and 5. Alright, so that's x, that's y, and that's z. And they give you a couple numbers. I'm going to give you different numbers than they do in the on the test, but let's just say that's 2 and, I don't know, let's say it's 7. Alright? And so you have to solve for x, y, and z. Those are the three separate problems. And I'm just going to go through it. I'm not really going to ask you how to do it or anything just because of time here. Got to get through 20 problems in less than a class period. So I don't know. Let's solve for or x first. I think in the other class I solved for z first, but in this case it really doesn't make any difference. You can do any of them. But let's just do x. X is actually a geometric mean. X, y, and z are all geometric means. Okay, just like we did that first problem. But it's the geometric mean between what two numbers? That's the only real difference between this. Yeah, because watch. It's the geometric mean between the whole thing. Johnny, what's the whole thing? Actually, let's put the geometric mean here. Okay, it's the whole thing, which is what? Give me numbers. 9. I thought I just said I wasn't going to ask you questions, was I? That's just part of me, though. And then the closest segment, right? The one that's adjacent to it. All right. So x is a geometric mean. This leg right here is a geometric mean between the whole thing and the segment that's adjacent or next to that leg. And then you just cross multiply. So it's x squared equals 9 times 2, which is 18. And then you square root both sides, so x is equal to the square root of 18. Now technically this does simplify. I'm not going to make you simplify it, but I just want you to keep it just like that. I don't want a decimal answer. I just want the square root of 18. It's the easiest way to do it, okay? Don't try to put it into a calculator. Let's do another one. Let's just go in order. Let's solve for y. Y is very, very close to solving for x because it's also another leg of the triangle. So I put y here and here. It's the geometric mean between what and what? Again, between the whole entire hypotenuse, that whole thing. It's 9. You see where I get the 9? 2 plus 7. And the side that's adjacent or next to that y, which is what? 7. So it's not 9 and 2. It's not 2 and 7. It's 9 and 7. Cross multiply. Y squared equals, what's that, 63. Again, technically this does simplify, but I'm going to let you just keep it like this. Alright, just keep it like that. And we have one more to do. We have to solve for z. So let's get z. Z is also a geometric mean. Between what and what? Just the 2 and the 7. Okay, that's real easy. So really, the first 4 problems is all about geometric mean. You better know how to find the geometric mean, because if you don't, you've missed 4 problems. And that's not a good start, is it? So I've got z squared equals 2 times 7 is 14. Take the square root of both sides, and it's the square root of 14. That's it. All right, so we're up to number 5. Now you're going to have 3 problems. I don't think this is on that little review thing that I gave you, but you're going to have problems like this where they give you 3 sides, and you have to determine if those 3 sides are a triangle, and if they are a triangle, if it's what? Right, acute, or obtuse. Do you remember that? So let's just give you 3 sides. What if I said I had side 3, side 5, and side, oops, let's use commas. Would I say 3, 5, and I don't know, let's just say 10. First of all, do those 3 sides make up a triangle? Why not, Ivy? Tell me why. 2 smaller ones. Right, the 2 smaller ones. It's not always the first 2, okay? I mean, they could be in a different order, but in this case they are in order, but the 2 smaller ones need to add up to be bigger than the third one. Do they add up to be bigger than the third one? No, they don't. So, what is this? It's not a triangle. So I just say not a triangle. So you can't say it's right, acute, or obtuse because it's not even a triangle to begin with. All right, there's no way you can manipulate those sides in order to even make it a triangle. What if you had this? What if you had 2 and 10 and, yeah, we'll say 11. Is that a triangle?
Yeah.
Yeah, it is, because the 2 smaller ones, 2 and 10, they do add up to be bigger than the third side. They have to be bigger. Then can they be equal? Could I have 2, 10, and 12? No, because the 2 and the 10 have to be bigger than the third one. Not equal to, they got to be bigger. So yes, this is a triangle. But now we have to determine what kind of triangle is it. Is it right, acute, or obtuse? We have a little way to do that. We go c squared, and we compare that to a squared plus b squared. What does the c represent out of these 3 numbers? The largest one, right, okay? It represents the largest one. The a and b are the 2 smaller ones. It has to be in this order. Make sure you put the c first. Don't go a squared plus b squared and compare it to c squared. Put the c first, okay? I noticed on a quiz, I can't remember which class it was, but I know some people did that. They compared it the wrong way. So take the c and compare it. So what are we going to do to that c? We're going to take that 11, we're going to square it. Then we're going to take those other 2 numbers, square them, and add them up. So let's take the 2 and square that, plus the b, which is 10, and let's square that. Let's see what we get. What's 11 squared? It's 121, isn't it? 2 squared is 4, plus 10 squared. What's 10 squared? It's 100. So that's 104. Do you remember what the rule is here? If c squared is greater, what kind of a triangle is it? It's obtuse, right? If c squared is greater than a squared plus b squared, it's obtuse. What if c squared was less than? It's acute. What if c squared was equal to? Then it would be right. What is it in this particular case? It's obtuse, right? Because c squared, right, is greater than the a squared plus the b squared, isn't it? 121 is bigger than 104. So what kind of a triangle is this? This is an obtuse triangle. So that's going to be 6, 7, and 8. All right, 6, 7, and 8, there's 3 of them are going to be like that. Make sure you figure out if it's going to be a triangle to begin with, because there could possibly, I don't have the answer key in front of me, but there's possibly one of them that is not even a triangle, okay? All right? Possibly. I don't know for sure. All right, let's do another one. Let's do Pythagorean theorem. Everybody remember that? Okay, let's see if we remember how to use that. If you really need to go. Let's just put some numbers in here. Let's pick some real crazy numbers, and we'll make that x. All right, now if I asked you to solve for x, what's Pythagorean theorem? Yeah, you could start with the c if you wanted to, but yeah, that's what it is. Now the c has to be which one on that right triangle? Has to be the hypotenuse. Okay, so this is the c. These 2 numbers right here are your a and b. All right, so you just plug them in. Watch, 15 squared plus 27 squared equals c squared. Remember that? Let's use a calculator for this. What are you going to do to get c by itself, though? Square root it. Square root it. Okay, so let's do this. Let's go 15 squared plus 27 squared. Definitely use a calculator for this. That equals that number right there. Is that my answer, 954? No, there's no way that side right there is 954 when the other 2 sides are only 15 and 27. Wouldn't you agree? So you got to take the square root of that, right? So take the square root of that answer, and then you get 30 points. It says round to the nearest tenth. Okay, it says specifically on the test how far to round it. So you must round it to that decimal place. What would this round to if I said round to the nearest tenth? 9.9, right, because this is the tenths place. You look to the right of it, right here. Okay, that 8 rounds that 8 up to a 9, so it's 30.9. So C would be 30.9. Now the numbers are going to be different, but the problems are very, very, very close to this. Just the numbers are different, that's all. All right, so I'm practically putting this in your lap, this test right here. All right, so take advantage of it, for goodness sakes. What's that? These are 2. This is 9 and 10. All right, so that would be number 9 on the test. Yeah. Yeah. Goodness gracious. You guys got to go to the doctor or something, get your bladders checked. All right. This is 11. This is X. And this is, I don't know, let's make something up. Let's say it's 17. Okay? All right, what if we had this? This is a little different. It's pretty much the same thing, but it's a little bit different. Here's what a lot of people do. A lot of people just see the 2 numbers, and guess what they do? They just go 11 squared plus 17 squared automatically. Okay, maybe some of you have done that before. But what do? What do we square and add up? The x and the 11, right? The legs, the 2 legs. So I go x squared plus 11 squared. Don't just automatically take the 2 numbers, square them and add them up. It's always the 2 legs squared and added up. Equals the hypotenuse squared. All right, that's the c squared. Now you have to do a little bit of a different math with this. You have to get rid of this 11 squared. How do I get rid of that 11 squared? It's being added. Come on. All right, you won't talk to me. I'll just do it. Minus 11 squared. So you've got to subtract it. That's very important. So let's come over here. Now we can put it into a calculator. So I've got 17 squared. And notice what I'm doing. I'm putting it into the calculator all in one shot. Okay, I'm not putting 17 squared, writing it down. Putting 11 squared, write it down. Then subtract it, and then write that down. Am I? I'm just throwing it all in the calculator one shot. It's makes things go a little faster. All right, so that's 168. My answer is not 168, though. I have to take the square root of that. 168, and that's 12.96. Now, what if it came out like this? This is a little bit weird. We talked about this when we took the quiz. It's 13.0, right? Because that 6 rounds this 9 up to make it a 10. You got to borrow the 1, right? Put the 1 over top of it, and that's going to be a 0. So that'll actually be 13.0. And it's important to have the 0.0. I know you don't think it is, but if I say to round it to the tenths place, you must have a tenths value. Even if it's 0, you have to have it there. Everybody with me? The numbers obviously are going to be different on the test, but, and I don't know if you'll have a 0.0 on the test. I really don't know. Don't have the answer key in front of me, but that is a possibility, so make sure that you do it correctly. All right, let's do another one. Let's go to some of our special triangles. All right, why were they so special? What was that first special right triangle that we did? 45, 45, 90, right? Okay, so that was our first special right triangle. So let's say that was 45 degrees. Now I made this very, very easy for you. On the quiz, I probably gave you the hardest possibility, the most difficult one. But on this, on the test, I actually gave you the easiest. So let's say that was 15. Let's just make a number up. It's very simple in this situation. Now, I could have given you the hypotenuse and asked for the leg. That'd be a little bit trickier. You have to do a little work for this. On this one, you don't have to do any work at all. All you got to do is look at it and then know the relationship. All you got to do is remember the relationship. And what is the relationship? Is it 30? That's what people were doing on the quiz. It's not 30. This is not twice as big as this. What is it? That's right. It's the square root of 2 times as big as this. The square root of 2 is like 1.4. So it's not 30. It's going to be smaller than 30. So all we write is, look, 15 square root of 2. That's all you do. There's no real arithmetic involved, is there? You just take the leg, stick a square root of 2 next to it, and you're done. That's it. I couldn't make that any easier, could I? You just have to realize it's square root of 2, though. Okay, know your relationships. I'm not going to write all those relationships down. I've done that for reviews on the quiz. I did it on when I taught the lessons. You need to go back and look at that. So it's good that you watch this video of this review, but you may want to go back to some other ones and find out some of those relationships that we talked about. We had another one. That's a 45, 45, 90. What's the other triangle? 30, 60, 90. So let's draw one that looks like that. Now, in this one of 45, 45, these two legs are exactly the same. Is that true about a 30, 60, 90? No. We have a what? A long side, a short side, and the hypotenuse, correct? So if that's 30, that has to be 60. And again, I make this one, let me make sure. Actually, I give you two of these. So this is 11, 12, and 13. I make one super easy. So watch this. This is just as easy as that 45, 45. It's easy if you know the relationships, okay? And when I say it's easy, it really is. There's no work involved at all. But you have to know these relationships. What is the relationship between the long side and the short side? 3, right. It's the short side times the square root of 3 on a 30, 60, 90, okay? So 30, 60, 90, it's the short side times the square root of 3. So watch what you do. You just do what? 8 square root of 3. It's as easy as that. And the problems on the test are going to be exactly the same. Instead of this being an 8, it's going to be some other number. Instead of this is 15, it's going to be just another number. All right, it's just as easy. Now, they do give you one more. I made it up, okay? So, I give you another one. Let's draw the triangle a little bit differently. It looks like this, but it's really not. That shouldn't cause you too much grief, just because we turned it upside down. That's still 30 degrees right there, and this is 60 degrees right here. They want you to find this side, which is the hypotenuse, and let's say that side is 5. Let's see what we have here. Now I've got a long side and I've got a hypotenuse. This one's a little bit more involved, all right? It's not as easy as the other two. The other two, you just look at it, write down, and answer. This one's a little bit more involved because the instructions for 11, 12, and 13, these three problems, these last three problems I'm doing right here, it says all the answers should be exact and simplified, and even in parentheses I put no decimals. All right, I couldn't be any more clear. They have to be exact, which means if they come out to a square root, you got to keep the square root with it. They have to be simplified, and that's what we're going to have to do on this problem right here. We're going to have to make sure we simplify it. No decimals. Everybody got me on this? Okay, it says it. Bold and underlined. That's like shouting at you, right, on paper, basically. I'm trying to get your attention. So you follow the instructions. So what do we have to do? I can't go directly from the long side to the hypotenuse. I'm going to have to go to the what? Got to go to the short side, okay? I have to find the short side. Now remember, when I knew the short side, what did I do? I multiplied by the square root of 3 to get the long side. What am I going to have to do in the other direction? What if I already know the long side? What will I have to do to get the short? I divide by the square root of 3. But do I want to keep my answer like that? Is that simplified? Why isn't that simplified? Good. You can't have a square root where? Is a denominator. So how do you get rid of it? You multiply top and bottom by whatever the denominator is. All right, what's that give you? 5 square root of 3 over 3. Okay. Now that's not our answer because we're trying to find the hypotenuse. What's the relationship between the hypotenuse and the short side? It's times 2. It's twice as big. So how in the world do I multiply that by 2? It's really not that hard. Watch. If I multiply this by 2, 2 over 1, what am I really multiplying by 2? Just the 5. 5 times 2 is 10 square root of 3 over what? 3. Just like that. Okay? So really, only two real math things you had to do. You had to know that relationship to get this. But then, what was the first math thing? Was to get rid of the square root in the denominator. We've done that over a dozen times. Wouldn't you agree with that? Yeah, we've done that a bunch. All right. So at this point, you got to catch on at some point. Okay. There's only so much I can do for you. You're gonna have to do a little bit of legwork on this yourself. All right. So you get this, multiply by 2 because that's the short side. The hypotenuse is twice as big, and you're good to go. All right, so that's 11, 12, and 13. Let's keep on moving. So let's do some trig. Starts off real easy trig. I'm telling you, some of these problems, like these two problems right here, they would just take a matter of just a couple seconds. Wouldn't you agree with me? Just a few seconds to do. Okay, not 30 seconds, not even 15 seconds. You should look at that and say, oh, 15 squared of 2. Boom. How long that take? Like 3 seconds? By the time you write it down, maybe 5 seconds. All right, it's real. Literally, that's how long it should take you to do that problem right there. Same thing with this one right here. Of course, this one takes a little bit longer, but this problem right here takes probably just about the same amount of time. They'll give you a triangle, a right triangle, and I'm just gonna, these aren't the numbers on the test, but I'm just gonna make it easy for us, okay? I'll make nice whole numbers. So let's say 3, 4, 5, and they're gonna say, let's call this A, B, and C. They're going to ask you to find the sine, cosine, and tangent of a couple of these angles. And we've done this before. Remember I had a worksheet. Remember that? You had to find like 6 different things, you know, and all you had to do was write it as a fraction. And that's all we have to do here. So they may say, find the sine of angle A, let's say. Okay, the sine of angle A. Well, here's angle A. What's our trig functions? Remember our little way to remember it? So, ka, toa. All right, so we have to do the sine, don't we? Which is opposite over hypotenuse. Here's the angle A. Which one is opposite angle A? 4. Which one's the hypotenuse? That's it. You don't even have to find the actual angle. All you have to do is find the sine of the angle. It makes it really, really easy. That's it. I circled it. That's the answer, right? Let's do one more, because they give you 2 of these to do. What if they, let's go tangent this time. What if they said, what's the tangent of angle C? Then look at tangent. It's what?
Opposite.
Right. So which one is opposite angle C? 3. And which one's adjacent to angle C? 4. So I just write 3 over 4, and that's it. Very easy. You got to know stuff, right? It doesn't say to solve it. It says find the sine of angle A. It doesn't say solve for angle A. It doesn't say find angle A, does it? It just says find the sine of angle A and the tangent of angle C. That's all it asks for. It doesn't ask you to solve it. Now the next problem, you're going to have to solve, okay? So that's actually 2 problems. That's 14 and 15. We're rolling right along. Again, that's a real quick one to do, isn't it? That's real quick and easy. I mean, just a matter of a few seconds. To think about it. I'll give you 10 seconds on that one, okay? Maybe 10 seconds to remember which one's sine, cosine, and tangent. You just write it down. No arithmetic needed. Really pretty simple. All right. Now we're getting into the real trig stuff. This does take a little bit of work, okay? This does take a little bit of calculator. It takes a little bit of algebra. Can't give you all the problems that only take 5 to 10 seconds, can I? You wouldn't want that, would you? That'd be too easy. You'd be embarrassed, wouldn't you? Did something like that. Maybe not. All right, let's look at this. We got to solve for x. Can you use one of those 45, 45, 30, 60 special triangle dealies? No, you can't, because it's 37 degrees. There's nothing real special about 37 degrees. Sorry about 37 degrees. Hope I didn't hurt his feelings, but there's nothing special about it, okay? But what we can do is we can do a trig function to solve for x. I know an angle, know a side. I can find one of the other sides, and I have a right triangle. So let's label it. Remember those problems where we label the sides and stuff? So look at the 37 degrees. What is this x? This side x to the 37 degrees? It's opposite. What is this 9 to the 37 degrees? That's adjacent. So we remember our trig functions. I'm not going to write it down. You probably already have it on your paper. What uses opposite and adjacent? The tangent. It's the tangent of that angle that we picked out, 37 degrees. It's equal to the opposite over the adjacent, which is x over 9. And then that's right. Now it's easy. It's real simple algebra right here. X is already on the top, so we just multiply both sides by 9, throw that into the calculator. Now, when I say just throw that into the calculator, for some people, you're having trouble with using your calculator. So let's go through it very, very quickly here. If you have a calculator similar to this, you probably don't have too much trouble with it. So you just hit 9, tangent, 37 equals, and there it is. Now, these problems say if it's a side, round to the nearest tenth. If it's an angle, round to the nearest degree. So what are we finding here? We're finding a what? A side. So we're going to round it to the nearest what? Tenth. So what is that going to be? We look to the right, so 8 rounds that 7 up to an 8, right? So it's 6.8. So x would be 6.8. Okay? I gotta keep going because we only got a handful of minutes here. You can always go back and look if you think I'm going a little too fast. Yep. That was number 16. Okay, here's another one. Looks just like this. And let's put some, let's go this purple color. Let's say this is 3. Let's say this is 12. And let's say this is x degrees right here. Okay? And you have to solve for x, obviously. So we solve for x. Let's do some labeling again. What is this 12? That's hypotenuse. What is that 3? It's adjacent. So which trig function uses adjacent and hypotenuse? AH. Aaron Hamrick. It's cosine. Right, it's the cos, C-A-H. It's the cosine. So what do we take the cosine of? The angle, right, which in this case is x. You always take the sine, cosine, and tangent of the angle. Don't ever take the cosine of 3 or the cosine of 12. Doesn't make any sense. You can only take the cosine of the angle. So what is that? It's AH, adjacent over hypotenuse. Which one is adjacent? 3 over hypotenuse, which is 12. This is where you do the inverse. That's right. When you solve for the angle, that's where you do the inverse, because I have to get rid of the cosine, so x is equal to the inverse cosine of 3 over 12. Now, 3 over 12 reduces, but I'm using a calculator anyway. I don't really care about reducing that right off the bat. So on this calculator, what am I going to do? I'm going to hit inverse cosine. See? Second function cosine. It gives me that little symbol with a -1. Then I hit 3 divided by 12. 3 divided by 12. You don't have to close it, but I'm going to. And then you just hit enter or equals, and there it is. Now, this is an angle. It says round the angle to the nearest degree. Not tenth, but to the nearest degree. So this would be what? It would be 76, right? Because you're rounding it to this decimal place, or this place value right here. So you look to the right of it. That 5 rounds that 5 up to a 6. So it's really 76 degrees. That's what that angle is right there. Okay? Make sure on your calculator you know how to do this. If you have a TI-30XA, you would do this. You would go 3 divided by 12, then equals. And then you would hit second function cosine, and then you would get your answer. Okay? Make sure you know how to use your calculator. And we've talked about that a lot. All right, we've got 3 more problems to do. That was number 17. Let's do number 18. Now, number 18 is not a right triangle. So what do you think we can use to solve for non-right triangles? Not sine, cosine, and tangent. What are the names? Tell you what, let's change that. Let's make this an 8 just to make it look a little bit more. Yes, the law of cosines are the law of sines, okay? That's what we're going to use when you have a non-right triangle, because this is not a right triangle. How do we know which one we're going to use? How do I know if I'm going to use the law of sines or the law of cosines? Well, let's see what I'm given. I'm given what? 2 angles and a non-included side. So this is angle, angle, side. Do you remember which one uses angle, angle, side? The law of what? Got to look that up. Okay, we wrote it down. We had a little list. Make sure you look over that list. We use the law of sines when it's angle, angle, side. Okay, so make sure you do that. Of course, you could have always found this angle Because 70 and 80 is what? 150. Take that away from 180, so this would be what? 30 degrees. So you could also say angle, side, angle, couldn't you? But isn't that the same? We still use the law of sines no matter what. Okay, for angle, angle, side, or angle, side, angle. So how do we use the law of sines? Well, what are we solving for? We're solving for x. So law of sines means a proportion, like this. If I'm solving for x, I'm going to put the x on the top. But what am I going to put below it if I'm using the x? I'm using law of sines and I'm using the x. I look where? I look opposite. So what do I put underneath it? Do I just put 70? It's called the law of sines for a reason. What do you think? It's the sine of 70, right? It's the sine of 70. Now look, if I put the side over the angle, what am I going to have to do here? This is the only other side that I know. So I got to use these two right here, don't I? See how I use the ones that are across from each other? So what do I put on top here? 12, right. Over what? Sine of 80. See it? Now why did I put x on the top? Because I want to solve for it. It's a lot easier to solve for a variable when it's on the top, when it's in the numerator. I only got to do one real math step here before I use my calculator, and that's to get rid of this sine of 70. How do I get rid of the sine of 70? Well, it's being divided, isn't it? So how do I get rid of something that's being divided? Multiply, right? So I multiply this by the sine of 70. And now I chuck that in my calculator. Let's do this quickly. Bell's about to ring. It doesn't look like we'll get to the end, but I'm telling you, go to the very end of the third period class, because there is a word problem. Number 20 is a word problem, and I set it up perfectly for you. We went over that right as the bell was ringing, so we pretty much came to the same spot. And there's a law. The next problem is a law of cosine problem. Okay, and that's on the third period one. So let's just put this one in a calculator and we'll be done. So it's 12 sine of 70 divided by sine of 80. And then hit equals, and there it is. Again, it's a side, so we're rounding it to the tenths place. So that 5 rounds this 4 up to a 5, so it's 11.5. So 11.5. All right? So check out number 19 on the third period class, and then also number 20, because that'll be on there. Please be ready for this. Please review the videos. Please practice these problems. Don't just sit there, watch the video, and then you think you're done. Practice, practice, practice.